Hello and welcome back. Today we're going to discuss the properties of real numbers. The properties of real numbers are the closure property, the commutative property, associative property, distributive property, reflexive property, transitive property, and symmetric property. These are your vocabulary words. If you want to, you can create little flashcards so that you can practice these. Okay, so first of all, these only apply to real numbers. And what are real numbers? Well, real numbers are most of the numbers that we deal with every day. The common numbers that we know, such as, I have it up here, 1, whole numbers like 1, 1/4, 3.14, that's pi. And as you know, pi goes on and on and on and on and on, and it infinitely continues with no end. But pi is a real number. All decimals are real numbers. All negative and positive integers, all whole numbers, the counting numbers, and fractions are real numbers. So basically, if those are real, then what is non-real? Non-real would be something like what you see over here, 8 over 0. The root of -3, because as you will learn, you cannot have the root of a negative number. But if that is in the math problem and you need to notate it, then you'll notate it as I, a lowercase I, which means imaginary. And then the other one over here is infinity. That's a non-real number, and it kind of looks like the number 8, but lying on its side. So, there we go. So those are some examples of non-real numbers that you might get to later when you do more complicated maths. Okay, so first of all, the first property is the closure property. And it simply states that the sum of any two real numbers is a real number. For example, 6 over here is the sum of 4 plus 2. And we know it's a real number simply because both 4 is a real number and 2 is a real number. And that's it. Okay, so the next one is the commutative property. And the commutative simply states that the order of which you add does not affect the order of which, the order of which you add does not affect anything. It does not affect the answer. And also the order of which you multiply does not affect anything. So, okay, this also reminds me, some of these properties apply to more than one type of problem. Okay, they all apply to real numbers, but some of them apply to, for example, addition and multiplication. And that's what the commutative property does. So basically, we all know that if you add 2 plus 22 plus 54, that you will get the same answer no matter what order these numbers are in. And the same thing with multiplication. If you have 4 times 4 times 17, then you're going to get the same answer no matter what order that you use. And this is something that we all know, we just didn't know the name of it. And now you do. Okay, so the next property that we have is the associative property. And it simply states that when adding, if you change the grouping symbols, it will not affect the answer. So the associative property only applies to addition. So let's try some really simple numbers here so I can explain to you what this property is. My parentheses always look kind of, parentheses always look kind of weird. Okay, 1 plus 2 plus 3 equals, and you can put this on your flashcard, your little practice cards if you're making them. The associative property simply states that these little parentheses do not affect the answer. So, when you're doing addition. So, 1 plus this group 2 plus 3 equals the same thing as this group 1 plus 2 plus the single number 3. You can switch the parentheses any way you like it when you're doing addition, and it doesn't matter. Okay, the distributive property. This one applies to multiplication only, and it simply states that you distribute a number outside the parenthesis by multiplying it by all numbers in the parenthesis. Okay, so let's just do a quick example of what they're talking about. Using simple numbers again. Okay, so let's just say you have 5 minus this little group of numbers, 4 minus 3. Did I say minus? I said times. 5 times 4 minus 3. That's right. Okay, so this is the same thing. Let me change the color so you can see the arrows. You take the 5, distribute it this way, take the 5 and distribute it this way, which makes it the same thing as 5 times 4 minus, and there was a better way. There was a better way to notate that. Hold on. Okay. Let's do this a little differently. Okay. So, when you have the 5 on the outside, and then you have something going on in parentheses, you just distribute that 5 amongst everything inside. And notice how there is nothing, let me change the color once again. Notice how there is nothing right here. This is very important. Where I'm doing this orange shading it in orange, notice that there's nothing right there between the 5 and what's going on in parentheses. There's nothing in between it. So that's how you know you're multiplying. If there were anything else there, like an addition, subtraction, division, or some other sign, square root, anything else, then you would not use the distributive property. You can only distribute like that when it's multiplication, and it simply becomes what you see over here. Okay, so the next one then is the reflexive property. And the true name is reflexive property of equality. But I didn't write it all out because I didn't have the room. So the reflexive property is all about equality, and it simply means that a number is equal to itself. Okay, so for example, let's take a variable, A. As soon as I get the right color, A equals A. Just the same as 1 equals 1. Just the same as 5 equals 5. Use these really simple numbers when you are learning this, because in your homework assignments, and especially on any quiz or test, there will be some type of algebraic, there will be a more complicated algebraic expression involved. I really don't think that you will ever see which property is this, and then it says 1 equals 1. You know, I remember doing this, and it was much more complicated. And what I should have done was just stick with the simple math and stick with the smaller numbers while I was learning everything, and it would have helped me to be able to see very clearly what is going on. So, yes, the reflexive property question that you're going to have, you're going to be like, what is that? You know, but it will simply be that there's an equal sign, and that what is on the left is going to be equal to what is on the right of the equal sign. Let's do something a little bit more complicated with that. Just a tad more complicated. And this will be multiplication, because with reflexive it works multiplication, addition, subtraction, division, you name it. This one will apply to all of them. Okay, this is something that you might see. 2 times c plus 3 equals 2 times c plus 3. Okay, and it can even be longer and more complicated. And one mistake that you could do is saying that it's the transitive property, or saying that it's the symmetric, because you'll be like, oh, well, that's the same thing. That's equal. That must be the symmetric property. But in fact, it's not. It's the reflexive property. Okay, so let's go on to the last two that we're going to do today, and that will be transitive and symmetric. Let me get the right color here. We're going to stick with green. The transitive property, the best way to describe it is like this. If A equals B and B equals C, then A and C are equal. A equals C and C equals A. So you can see how these last couple of properties, the reflexive, transitive, and symmetric, people sometimes get them confused because they're the ones that use the equal sign. But with transitive, it's A would equal C because if A equals B and B equals C, then it's kind of like you're drawing a conclusion based upon the aforementioned math. Let's see. Let me do one more example of that. If n plus 3 equals m plus 5 and m plus 5 equals 6, then n plus 3 equals 6 too. See that? If n plus 3 equals m plus 5 and m plus 5 equals 6, then n plus 3 equals 6 too. Those are kind of fun. Okay, and the last one is the symmetric property, otherwise known as the symmetric property of equality. All of these last three, the reflexive, transitive, and symmetric, are all properties of equality. And they will apply to, you addition, subtraction, multiplication, division, everything. Okay, not limited to a type of math problem. These are not. So the symmetric property of equality states that two quantities are equal. So let's do this. If A equals B, then B equals A. It kind of, let me scroll back up here for a second. Oh, it's kind of like the reflexive property. The reflexive property was A equals A. And this is if A equals B, then B equals A. So basically, reflexive would be like looking in the mirror. What you get out is exactly what you put into it, and it appears to be also in the same order, in the same exact order, because in this example, 2 times the grouping C plus 3 equals the same thing, but also is written in the exact same order. The 2 is exactly where it was over here. The C plus 3 is exactly where it was, and the brackets are in exactly the same place. It appears to be the exact identical same thing. But with symmetry, what you have on one side, what you have on this side right here, it's just going to be flipped around. So at first we had At first we had A equals B. Okay. And then after the symmetric property is applied, it's B equals A. So the difference would be in which one comes first. And the difference would be in what is on the left side of the equal sign and what is on the right side of equal sign. And you just pick it up and move it over to the other side. So we'll do an example with numbers now. If 12 equals 2 plus 10, then can you figure out what this is going to be? If 12 equals 2 plus 10, then getting real close to the bottom here. Then 2 plus 10 equals 12. So all you did in that example was, here was the equal sign, here's the equal sign. So all you did in that example was you took that 12 and you moved it from the left side of the equal sign to the right side of the equal sign, and the same thing with the 2 plus 10. Practice these last 3 properties together because they all use the equal sign, and the more complicated the math gets and the longer the series of numbers are that you're identifying, it can be kind of confusing. You're like, oh, that looks like the reflexive, or oh, that looks like the transitive, but I'm not sure, So what I would do when studying is I would do the closure, commutative, associative, and distributive. I would study those together because you're going to have to identify them from each other. Like there will be just some math. You'll be looking at some math. It'll say, which property is this? And it may be multiple choice. It may be fill in the blank. And it's easy to tell the difference between, let's say it's something over here, 2 plus 22. Hold on. Okay, let's say it's the distributive property 1. 5 times 4 minus 3, or whatever. Okay, well, you know that it's not one of the ones at the bottom. You know that that's not reflexive or transitive or symmetric because it doesn't have an equal sign in between two different expressions. So, you know that it's not one of those. But the confusion is between the ones at the top, closure, commutative, associative, distributive. And the confusion is these with each other, and then the ones at the bottom, reflexive, transitive, and symmetric with each other. Confusing them with each other. So keep that in mind when you're studying. And good luck, and stay tuned for the next video. We will probably do some identification of these properties. Okay? Thanks for watching, and good luck.